All right, this is January 2019, question number 2. AI says we're to make is asking us to make x the subject of the formula. All right, so right now this is an equation or it's a formula, and a formula is an equation, and right now y is the subject. When a letter is a subject or when a variable is a subject, its coefficient must be positive 1 and its power must also be positive 1. So in other words, if I want to make x the subject, or making x the subject means I must have x by itself on what? One side. Its coefficient must be positive 1 and its power must be positive 1. All right, so so we're starting off with y with we're starting off with y is equal to x over 5 minus 3p. Alright, so I need to have x by itself. Let's start by moving over to 3p. I can say that y plus 3p is equal to x over 5. Negative p goes over and become positive p. I can put this entire thing here over 1, and then I can say to myself, if I have one fraction is equal to one fraction, one way to eliminate the fraction or to get rid of the fraction is to cross multiply. So 1 times x up here, 1 times x up here is x, and this is equal to 5 times y plus 3p. Alright, and I'm guessing that we could leave the answer like that. This is not the only approach you could take to the question, but this is very much correct. An alternative approach, didn't have to do it, but let's just do it. Well, y is equal to x over 5 minus 3p. It's an alternative approach, almost the same thing. One thing I could do is I could put this over 1. And one way to, this is an equation with fractions. And when we are solving an equation with fraction, the first thing you need to do is to get rid of the fractions. One way to do that is to find the LCM, use the LCM, and then discard the LCM. So the LCM is 5. 1 into 5 is 5. 5 times y is 5y is equal to 5 into 5 is 1. 1 times x is x. 1 into 5 is 5. 5 times 3p is 15p. So I found the LCM. I use the LCM. So next I'm going to discard the LCM. So next I'll have 5y is equal to x minus 15p. Alright, I need to make x a subject, so I need to have x by itself on one side. I'm going to have what? 5y plus 15p is equal to x. Turn it around. This is simply saying x is equal to 5y plus 15p. Alright, so this is an alternative approach, and you'll still end up with the same answer. If you look carefully, you'll see that the two answers, that's the answer here and the answer here, they're both the same. Alright, so this is January 2019, question 2a, we're asked to solve the following equation by factorization. Alright, so this is a simple quadratic equation. We're going to solve it by the method of factorization. The first step in any factorization, or the first step when you're asked to factorize, is to see if there's a common factor. So by looking at this, I can see clearly that yes, I have common factors. X is a common factor, so I can factor out the x. So x into 2x squared is 2x, and x into 9x is 9, and this is equal to 0. So now I'm multiplying two numbers and I'm getting 0. I'm multiplying x by 2x minus 9 and I'm getting 0. Whenever you're multiplying two numbers and you're getting 0, it is either the first number that is 0 or the second number that is 0. Whenever you're multiplying, if you're multiplying two numbers and you're getting 0, it is either the first number is 0 or the second number is 0. So therefore, x is equal to 0 or 2x is equal to 9. So negative 9 goes over and become positive 9. Next, I'm going to divide both sides by 2. So x is equal to 9 over 2, or if I want, I could say 4 and 1 half. So my two answers are x is equal to 0 or x is equal to 4 and a half. So whenever you solve a quadratic equation, you must end up with two answers. Whenever you solve a quadratic equation, you must end up with two answers. All right, the B part of the question. This says a farmer wishes to enclose a rectangular plot with a wire fence. The width of the plot is 3 meters less than its length, L, and we're told given that the area enclosed is the area enclosed by the fence is 378 square meters, show that L square minus 3L minus 376 is equal to 0. All right, so this is our situation. There's a rectangular plot of land. The length of it is L. The width is 3 meters less than L. So this is the width, and it's 3 meters length less than the length, L. So this is L minus 3. So the length is L, the width is L minus 3. So now the area of a rectangle is equal to length times width, which is equal to L times L times L minus 3. And this area, we're told, is equal to 378. I'm going to remove the brackets by applying distributive law. L times L is L squared. Distributive law says whatever is in the bracket is multiplied by what is immediately outside the bracket. L times 3 is, this is minus 3L, and this is equal to 378. Positive 378 comes over and become negative, so therefore L squared minus 3L minus 378 is equal to 0. So is equal to 0. So that's what we're asked to do. We're asked to show that L squared minus 3L minus 376 is equal to 0, and that is what we just did. Alright, and this brings us to the last part of the question, the C part of the question. It says the force F applied to an object is directly proportional to directly proportional to the extension E produced by the object. I represent the information as an equation in terms of F, E, and an appropriate constant K. Alright, so this is a question in variation and I. In variation, you will come across maybe what? One or two operative words. I like to call them operative words, or words essentially that based on that simple word it gives you a direction. In this question, the word is directly. It's directly proportional. So that first statement, that variation statement, f um, is directly proportional to the extension e. Translate into this equation. F is equal to k times e. All right, so the variation statement, f is directly proportional to e. Translate into f is equal to k times e. I says the incomplete table below shows corresponding values of f and e. Use the equation obtained in CI to otherwise determine the value of x and y. All right, so um, typically a variation question is a four-step flow. Step one is to come up with this equation. The second step is to determine the value of the constant k. K is called the constant of variation. So to do that, I'm going to say when e is equal to 0.2, f is equal to 8. So I'm going to put that information into the equation to determine what is the value of k. So 8 is equal to k times 0.2. All right. So the opposite of multiplication is division. So I'm going to divide both sides by 0.2. So when I do that, I'm going to get k is equal to 40. All right. So I took a value, corresponding value of x and y to determine the value of the constant k. So now let's use this information to determine what is the value of x and what is the value of y. So I'm going to rewrite this equation and put in this new value for k. So now my equation is saying f is equal to k, which is 40 times e. All right. So when e is equal to x, um, f is equal to 25. So let's look at that. I'm going to say when e is equal to x, f is equal to 25. So when e is equal to x, f is equal to 25. So let's put that information in. I'm going to have therefore 25 is equal to 40 times e, which is x. Let's divide both sides by 40. I'm going to get x would be equal to 25 over 40, which is the same as saying 5 over 8. Alright, so I have my value for x. What I need right now is the value of y. I'm going to write back the same equation. F is equal to 40e. Alright, go back up to my table to see what's going on. And this is saying when e is 3.2, f is equal to y. So I'm going to write that when e is equal to 3.2, f is equal to y. So therefore, y is equal to 40 times 3.2. Y is equal to y is equal to 128. So the value of x is 5 over 8 and y is equal to 128.